Okay, so a molecule with polar bonds can be nonpolar, but why is that the case, right? Why is that? And for an example, we have carbon dioxide. So we have one carbon, two oxygens, and this is the Lewis structure. So to examine this, we'll examine one side, and one side shows that this is actually a polar covalent bond, right? And why is that? Because both of these, carbon and oxygen, are both nonmetals. But the thing is, they have different electronegativities, so this is going to be a polar covalent bond. Because both of them are nonmetals, but since they have different electronegativities, the atoms are going to be pulled to the oxygen. Therefore, the oxygen will have a negative charge here. Let me write that. It'll have a negative. Just means that it's a little negative. This symbol just means it's a little negative. And if more electrons are on this side, if more electrons are being pulled, that means it's going to be a little negative here, and it's going to be a little positive here, right? Because if you're losing electrons, you're going to become more positive. But if you gain electrons, it'll become more negative because electrons are negative, and the more electrons you have, the more negative you become. So this is a polar covalent. This right here is a polar covalent bond. So to demonstrate why this polar covalent cancels this one out, what is the reason why they cancel out? I think an illustration will help. So an example is a carbon, right? You can imagine carbon as a person, and let's say they have a hula hoop, right? So it's center. He's center in the hula hoop, and then you have an oxygen here on one side, and the oxygen pulls this hula hoop. So what happens? This carbon's hula hoop gets pulled to one side, and this oxygen is pulling on this hula hoop, and the hula hoop represents the electron density. So the electrons are now more on oxygen side. So oxygen is going to be more negative, and since carbon's losing it, it's going to be more positive on the other side, on carbon side. So now you have a polar covalent bond. But the thing is, if you have another oxygen, right? Another oxygen come here and pull on this hula hoop, what happens? The only reason why it's a little negative is because the electrons are being pulled in by oxygen, because this hula hoop is more on oxygen side. That's the only reason. If it's dead center, nothing happens. So what does this other oxygen do? It pulls on this side, right? So if both of these are pulling with the same amount of force, what happens? It becomes dead center. So the hula hoop becomes balanced, right? The hula hoop gets completely balanced. So even though on each side, individually, it would become polar, when you combine both of them, they end up canceling each other out because they're pulling with the same amount of force in either direction. Because oxygen is more electronegative, so they're pulling with the same amount of force, causing the electronegativity to stay center. Therefore, it will become nonpolar instead of a polar molecule. So the overall molecule becomes nonpolar, and that's why overall carbon dioxide is nonpolar. So I hope that helped, and thanks for watching.